This lesson is over absolute value inequalities. And really, it's just the same thing as compound inequalities. So we solve absolute value inequalities the same way we did with the equations. I take whatever's inside. First, I have to isolate it, and it is. So watch what I'm going to do. I'm going to split it in two, and I'm going to set the inside equal to the positive value of the other side, and I'm going to set it equal to the negative value. But when I switch this, I'm going to switch my sign as well. So the only thing different is that when you switch this to the negative sign, you're going to switch the direction of your sign. So now these are not in least to greatest order. So first I'm going to do that. So I'm going to put x is less than or equal to -5 over here, and I'm going to put x is greater than or equal to 5 over here. When I put it like this, I see my arrows. This one's going out to the left, this one's going out to the right. So right away, I know that they're going apart from each other. So this is an or statement. And you already know how to graph it. So it's closed circle on -5, it's closed circle on +5, and they go away from each other. And interval notation, of course, this guy starts at -infinity. Stops at -5, bracket around him. I must include the word or, and then I start at 5 and I go to infinity with a parenthesis. Okay, let's take a look at this one. So when the absolute value of x is less than or equal to 8, again, I branch it, I set the inside, equal to the positive value, and I set it equal to the negative value, and I switch my sign. Notice I want to write it correctly, so I'm going to bring this, because -8's less than that, I'm going to start over here. And when I write it like this, I can see that my arrows are going towards each other, therefore I know it's an and statement. And we don't write and statements like this, so we need to rewrite my inequality piece, and it would look like this. One variable here, I have -x, I have 8, and I remember the arrows are always going both ways, because when you look at it here, x is still greater than -8, but because it's on the other side, that's why we switch my signs, and x is still greater than -8. So they always go the same direction in that and statement. So I'm going to circle in -8, I'm going to close circle on +8, and they go towards each other. And of course, my interval notation is -8 to 8, both brackets. So what does this mean? It means that absolute value inequalities are really just compound inequalities. Inequalities. So when it's a less than, it's an and statement. And when it's greater than, it's an or statement. But you don't really have to memorize that, because when you work it out, you're going to be able to tell anyway. So we can, there's steps to doing it. One is we isolate the absolute value expression. Step 2 is just like we did up here. We create two cases. We can use the KISS method, which means keep it, switch, switch, to set up the two cases. So we'll talk about what that means, but you already know what that means. And then third step is to solve it. And then fourth, of course, we graph it, and then we write it in interval notation. So we already did 1 and 2 together. So let's take a look at number 3. So 3, again, my absolute value is isolated, so I'm good to go. Now I'm going to branch it. So I'm going to keep it. X minus 1 is greater than 6. That's the K. And then I'm going to keep x minus 1, and I'm going to switch my sign, and I switch my constant term. So keep it, switch, switch. Keep, switch, switch. So then I'm going to solve, add 1 to both sides, and I get x is greater than 7. Add 1 to both sides, and x is less than -5. Notice that these are not written correctly, so I should put x is less than -5 and x is greater than 7. When I do it that way, I see that the arrows are going apart from each other, so I know it's an or statement, and then it's already written in inequality statement. So when I graph it, it is open circle on 5, It is open circle on 7. X is less than -5. X is greater than 7. So interval notation, of course, is we start at -infinity and we go to -5 with a parenthesis, or don't forget to write that, 7 with a parenthesis to infinity with a parenthesis. All right, let's do some not harder ones, just more step ones. All right, so let's take a look at let's go down to the difficult ones. Let's look at number 8. So I can't have a fraction, so remember to clear out this fraction, I'm gonna multiply both sides by -2. And when you multiply both sides by -2, in your head, you should hear a bell going off and it should say ding, 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 switch that sign. So -2's cancel out, I've switched my sign, and -6 times -2 is a +12. Now my absolute value bracket is isolated, so I'm gonna keep, and then I'm gonna keep, switch, switch. And now I can solve. Add 8 on both sides. 4x is greater than or equal to 20. X is greater than or equal to 5. Add 8 to both sides. 4x is less than or equal to -4. And when I divide by 4, x is less than or equal to -1. They are not in the correct order, so I'm going to write x is less than or equal to -1 and x is greater than or equal to 5. I notice that my arrows are going apart from each other, so I know that it's going to be an or statement. Oop. And when I graph it, I'm going to bubble in -1, and x is less than -1, so it's all those numbers to the left of -1. I'm going to bubble in +5, and x is greater than, so it's all those numbers greater than 5. We already know it's an or statement. So in interval notation, it starts at -infinity, it ends at -1, blocked off, or it's going to start at 5, and then it's going to go to infinity. So that's what so absolute value, this lesson is just kind of meshing everything together. But let's do number 10. We'll do that last one together. First step is isolate the absolute value. So I'm going to subtract 11 on both sides. And then I have 1/2 with all my absolute value written inside. It's less than or equal to 4. And then to isolate that absolute value, I'm going to multiply both sides by 2. So now I have my absolute value, which is 4x minus 4. Is less than or equal to 8. Do you see what I did there? I just didn't write it. I was lazy. So when I multiplied both sides by 2, I got 4x minus 4 is less than or equal to 8. I shouldn't have been so lazy. So now it's isolated. Now I branch. So I'm going to keep this first one. And then I'm going to keep the inside, switch the sign, and switch. Okay, so solve. So I'm going to add 4. 4x is less than or equal to 12. When I divide both sides by 4, I get x is less than or equal to 3. Here I'm going to add 4 to both sides. 4x is greater than or equal to -4. And when I divide by 4, I get x is greater than or equal to -1. This is not written in the correct order, so I'm going to put x is greater than or equal to 1 and x is less than or equal to 3. Now that it's in, x is greater than or equal to -1. So now when it's in this direction, I can see that my arrows are going together and it's an and statement. So this isn't written correctly. Remember the and statements, I have x is in the middle, -1 to the left, +3 to the right. This guy direction remains the same. And this guy, because it's symmetric, I'm going to flip that sign and that's what it looks like. So I'm going to bubble in -1. I'm going to bubble in +3 and they go together because of course that's an and statement. And when I write it, I'm going to block off -1 and I'm going to block off 3. So hopefully that's easy and a refresher for you. Come see me if you have questions.